Okay, we'll take a look at number number 3 though. Square root of negative 5 squared. And this one's pretty obviously equal to negative 5. But let's be do this kind of systematically. We're going to write square root of negative 5 as square root of 5 times square root of negative 1 squared. And then this is square root of 5 times I squared, which is square root of 5 squared times I squared, which is 5 times negative 1 or negative 5. Okay. And I took it through this kind of this process because sometimes you get a result that's actually kind of surprising, like in the next example. Square root of negative 2 times square root of negative 3. Your first instinct might be to say that this is square root of 6 because you're thinking that you want to multiply inside the square roots. That only works for positive numbers or 0 inside the square root. When you have negatives in there, you first have to convert them to write them in terms of multiples of I. So square root of negative 2 is square root of 2 times I, and square root of negative 3 is square root of 3 times I. Now we can multiply inside the square root, so it's square root of 6 times I squared. I'll go ahead and write that, I squared, which is square root of 6 times negative 1. This negative 1 is on the outside of the square root, so that's equal to negative square root of 6. Not the positive square root of 6, so just be careful with that. Let's continue on. Let's skip 5 because it's very similar to 6. Let's look at 6. I minus 6 plus I plus 4 minus 2I. So this is just adding and subtracting complex numbers. Oh, and I guess if we wanted to write this in standard form, technically we could say negative square root of 6, that's a real number, plus 0I. But negative square root of 6 is fine. Okay, if we're adding or subtracting complex numbers, just combine like terms. So I minus 6 minus I minus 4 minus 2I. I minus I is 0, so we end up with negative 10 minus 2I. So just combine like terms, real and imaginary when you're adding or subtracting complex numbers. We're going to skip 7, that's just distributing. I think it's fairly obvious to see how that works. And we're going to jump to number 9. It's similar to number 8. So 5 minus I times 1 minus 2I. And the important thing to remember about this one is just a FOIL. So first is 5, outer, minus 10I, inner, minus I, last, plus 2I squared. So just be careful with the negatives, with the i's. It's you really got to keep track of your negatives. Negative times negative is positive, so positive 2I squared. This is going to become a negative 1, but maybe we don't want to do all that at once. And we might be inclined to make a mistake. So 5 minus 11I, combine those like terms. I squared is negative 1, so this becomes minus 2. Combine like terms again, we have 3 minus 11I. Okay, so just foiling and keeping track of your negatives, easy enough. Let's look at number 11. We're going to skip 10 because it works the same way as 11. Negative 3 plus I over 4 minus 3I. Now remember, we want to actually write this in standard form, A plus BI. It's a complex number in standard form. Right now, it's a complex number divided by another complex number. And it's not maybe immediately clear how to simplify this, but we're going to use a trick that is going to become quite common actually, and that's going to be to multiply this fraction by a clever form of the number 1. And the clever form I'm going to choose is 4 plus 3i divided by 4 plus 3i. And I chose that because 4 plus 3i is what's called the complex conjugate of 4 minus 3i. And that is important for reasons that you should be able to see once we actually do this multiplication. So I'm going to FOIL the denominator first. So 4 times 4 is 16, minus 12i, minus another, or plus 12i. I'll go ahead and write this out. Minus 12i, plus 12i, minus 9i squared. And then we'll FOIL the numerator, negative 12 plus 4i, minus 9i, plus 3i squared. And then if you look at the denominator, because we multiplied by that conjugate, the middle terms are going to cancel. And they'll always cancel when you multiply by the conjugate. So now we have 16 minus 9i squared, and the I squared is equal to negative 1. So the denominator here is really just 16 plus 9, or 25. And the thing is, when you multiply by that clever form of 1, which is the conjugate divided by the other conjugate, you're always going to get a real number in the denominator. And that's going to be important in the simplifying, as you'll see here in a second. I'm going to clean this up a little bit. The numerator, 3 times I squared, that's 3 times negative 1, or minus 3. So minus 12 minus 3 is minus 15. 4i minus 9i is negative 5i. Okay. And what I'm going to do now, because we have a single term in the denominator, it's not the two terms, I can actually, and it's a real number, I can actually split this up and make it negative 15 over 25 minus 5i over 25, which I can write as, I can reduce this as 3 over 5, so negative 3/5. And I can reduce this as 1 over 5. And I'm going to go ahead and write that as a fraction times I, so minus 1/5 I. There's our complex number in the standard a plus bi form. And the trick to that was, again, multiplying by the complex conjugate over itself, which will always give you a real number in the denominator, which will always allow you to split up those two terms. Okay, one more example. Here. 2 over 3 minus I minus 5 over I plus, or 1 plus I. 2 over 3 minus I. What was it? Minus 5 over 1 plus I. Last example is similar to the previous one, but just with a little twist at the beginning. 2 over 3 minus I minus 5 over I plus 1. And I'm looking at this number 12 here. The thing is, when you're trying to subtract two complex numbers in sort of non-standard form, if they've got denominators that are complex numbers, you first want to find a common denominator, and the easiest way to do that is to just multiply the two denominators. So 1 plus I over 1 plus I, that's what we're multiplying the left term by, and the right term we're multiplying by 3 minus I over 3 minus I. Notice I'm not multiplying by conjugates, I'm just multiplying by the denominators themselves. So then in the numerator here, or in the denominator at least, we've got 3 minus I times 1 plus I. In the numerator, we've got 2 plus 2I minus 5 times 3 minus I. So that minus is going to have to be distributed here. I'll do that in the next step, or I'll actually just do it now. So that becomes minus 15 plus 5I. So 2 minus 15 is negative 13. 2i plus 5i is plus 7i. That's in our numerator. In our denominator, I'm going to go ahead and FOIL that. That's 3 plus 3i minus I squared. Negative 13 plus 7i over this I squared becomes negative 1, so minus negative 1. 3 minus negative 1 is 3 plus 1 or 4 plus 2i. That's our denominator. So now we're back at the situation we were in the previous problem. And now, to write it in standard form, now we multiply by the conjugate. 4 minus 2i over 4 minus 2i. And let's see what happens. Oh. Let's see what happens when we do that. The denominator becomes a real number. It becomes 16 minus 4i squared, which I'll simplify a little more in a second. The numerator becomes negative 52 plus 26i plus 28i minus 14i squared. The I squareds I can write as negative 1, so the denominator becomes 16 plus 4 or 20. The numerator, once this becomes a negative 1, we can combine like terms. Negative 52 plus 14, negative 38, and then 26i plus 28i is, oh, not 58, 54i. And the last step would just be to separate these two terms, which we can do now that we have just a single term in the denominator. You can write it as negative 19 over 10 plus 27 over 10i. There you go. Okay, I'm going to post a homework on the Moodle along with this video. I hope you guys watch it and enjoy the rest of your weekend. Thanks.